Let F1 and F2 be the two forces which are coplanar and concurrent acting at the point O. So let theta be the angle between these two forces F1 and F2. Now I am representing these two concurrent forces F1 and F2 on the two adjacent sides of the parallelogram. Now you can see OA and AC are the two adjacent sides of the parallelogram on which I am representing these two forces F1 and F2. So taken in the same order. Then the diagonal of the parallelogram will represent the resultant of these two forces F1 and F2. The angle taken between these two forces F1 and F2 will be theta. So let OA and OB represent the two forces F1 and F2 respectively, both in magnitude and direction. The magnitudes are given by F1 and F2 and the directions of these two forces are shown here. So the resultant R of these two forces F1 and F2 will be obtained by completing this parallelogram. So the dotted lines used is now completing the entire parallelogram. The diagonal OC represents the resultant R. To prove this parallelogram law of forces, we are extending this parallelogram by dropping a perpendicular from this point C on this given force OA. So the perpendicular drawn from C will intersect the line OA at the point D. So since this is the angle theta and this is the external angle for this parallelogram. So these two angles are one and the same. So theta and theta. So now F2 is considered as the inclined force. So F2 cos theta is the horizontal component of this force F2 and F2 sin theta is the vertical component of this force F2. F2 cos theta and F2 sin theta. Then from the figure, so we can see that OC, so that is OC is now the hypotenuse of this right angle triangle. Now ODC is a right angle triangle. So OC is the hypotenuse. OD and DC are the other two sides of the right angle triangle. So I can using a Pythagoras theorem. So OC square is equal to OD square plus CD square here. So that is what written here. So OC square is equal to OD square plus CD square. So OC is equal to square root of OD square plus CD square. From the diagram, OD can be written as OA plus AD. So where OA is nothing but F1 and AD is nothing but F2 cos theta. So I am writing OD as OA plus AD. So that is nothing but F1 plus F2 cos theta. F1 plus F2 cos theta the whole square. Then CD. So this CD is nothing but F2 sin theta. So it is F2 sin theta square here. So expanding this F1 plus F2 cos theta whole square as F1 square plus F2 square plus 2 F1 F2 cos theta. Then this F2 square sine square theta. Now, considering this uh, F2 cos theta square, so that is F2 square cos square theta. So, taking this F2 square cos square theta plus F2 square sine square theta. So, F2 square is common. So, it becomes F2 square into sine square theta plus cos square theta. We know that sine square theta plus cos square theta is equal to 1. So, this summation of these two will become F2 square here. So, I have now F1 square plus F2 square plus 2F1 F2 cos theta. So that is the resultant force. So if this F1 and F2 are the two forces with the angle 90 degree here. That is F1 and F2 are perpendicular to each other. So then theta becomes, the angle between these two forces F1 and F2 becomes 90 degree here. So that means theta becomes 90 degree here. So then cos 90 is 1. So cos 90 is 0. So this entire thing becomes 0 now. So it is r is equal to square root of f1 square plus f2 square. If alpha is the inclination of the resultant with the direction of the force f1. So alpha is the angle made by the resultant r with this OA. So then we can write from this right angle triangle. So tan alpha is equal to opposite side f2 sine theta, that is f2 sine theta divided by the adjacent side OD. So that is nothing but f1 plus f2 cos theta. So f1 plus f2 cos theta. So these two equations will give you the magnitude of the resultant and the angle made by the resultant. As I said earlier, if f1 and f2 are perpendicular to each other, so if f1 and f2 are perpendicular to each other, this theta becomes 90 degree. So cos 90 becomes 0. So this entire quantity becomes 0. R remains a square root of f1 square plus f2 square. If theta is 90 degree, so here sin 90 is equal to 1. So this becomes f2 into 1 divided by f1 plus f2 cos theta. So cos 90 is 0. So this is entire thing is 0. So I have in the numerator f2 divided by denominator f1. So alpha is tan inverse of f2 by f1. In general, so f2, that is the vertical component of the force. So I can write the general equation of as tan inverse of this f2 is nothing but the vertical component. So that is fy, and f1 is the horizontal component fx. So the angle made by the resultant is tan inverse of fy by fx. Polygon law of forces. If a number of forces acting simultaneously on a particle are represented in magnitude and direction by the sides of a polygon taken in the order. That means I am showing the forces acting simultaneously on a particle are represented by the sides of a polygon taken in the order. Then their resultant will be represented in magnitude by closing side of the polygon. So these are the forces taken in the order. So if the resultant comes in the same order, then the resultant has to be in the downward direction, but the resultant is now taken in the opposite order. So you can see this example, another example of four forces F1, F2, F3, F4. So they are represented on the sides of the polygon here. Thank you.